Recording. So once again, thanks everyone for attending the Environmental Express webinar series. This is our third one of the year for our third Thursday webinar. And once again, yes, I know this is not the third Thursday of the month, as with last month, with the first day of the month starting on a Thursday, being Thursday. The third Thursday comes a little faster than normal, so we moved this one to the fourth Thursday. Hopefully, in the ensuing months, we will return to our regularly scheduled actual third Thursday schedules. This month's presentation is on sample collection, and everyone give yourself a little round of applause. We've actually achieved a personal record for us for our webinars as far as number of people registered for it. And I'm hoping that we'll hit an attendees record as well. That should correspond. We do usually there are people who cannot attend but register so they'll get the recordings later, and that's fine. That's perfectly okay. So my name is David Smith. I am the technical director here at Environmental Express, and as normal, I will be presenting the webinar. And let's go ahead and get going. Our topic is sample collection. I am not going to go into step-by-step, do this, do that, write this down, make sure to document here, make sure to stand on one foot and burn your incense kind of steps. Mostly because those things are covered in your SOPs and will possibly dictate or differ from one another as dictated by your state or by the program area or whatever else. So we're not going to go into step-by-step things. What we're going to talk about is overarching principles and concepts for sample collection and how it all fits into the overall realm. Sample collection people, you guys are actually pretty darn important. And even though sometimes it may not feel that way from how your lab people treat you. Lab people, when you're listening, treat your sample collection guys, your field guys, with some good respect. They do a lot of hard work and get stuff ready for you. So let's start out by discussing who is responsible for our good analytical results. And obviously, the very first thought is it's the lab, the people doing the analysis. You've got responsibility to make sure you've got good data out there. However, it actually starts before that, as is possibly evident by our webinar today. It starts maybe back at sample collection with the field personnel. If you don't get good samples in the lab, then any data you generate is going to be not good as either. Garbage in, garbage out, as the computer programmers tell us. If the samples come in and they're no good, they've been handled improperly and are not representative of what you're trying to analyze, then the data that you generate from them is useless. And actually, there's a little bit further back that it goes. We've got a bottle provider or a container provider, the people who are getting you the stuff that you're putting your samples inside of. They've actually got some responsibility too to help you ensure a good analytical result. If your container is no good, then anything that you put inside it is going to be no good, and bringing it to the lab, the data that you then generate will be no good. So the actual answer, of course, is all of the above, as well as other people. There's lots of people involved in the generation of good analytical results and data. But of course, today we're going to talk about sample collection, field personnel. The role of our, hold on, let's see here. Oh, there we go, okay. Needed to get a few things out of the way so I could see a full screen. The role of our sample collection people. Obviously, you're providing the lab with work. Without you, the lab doesn't get anything to do. You're the face that the customer sees most of the time. You are the physical representation of your lab and the people who are doing your work. You've got to make sure that the right samples come in. Yes, there are samples that get mailed to you, shipped via courier or something. But for the general day-to-day routine stuff, you are making sure that the right samples get in there, that everything is labeled properly, that everything's in the right containers, that when the lab gets it, they know what they're working with. Along those lines, you document. There are all sorts of things that need to be recorded by your field service personnel. Chains of custody, bottle labels, which I guess are part of the chain of custody, any kinds of receipts in and out, notes about problems you may have encountered, anything. Sometimes you've got those fun data loggers that actually track where you are and what site you have pulled samples from. PPE, keeping it clean. Keep yourself clean so that you don't contaminate the samples, and have your sample collection containers ready. Have the right number, have the right sizes, have the right preservatives, have the right everything that you need to make it happen. So there's a lot that goes into your sample collection, a lot of things that you have to keep up with to make it all work right. How do the basics of getting your samples? Two choices really, automatically collect samples or manually collect samples. And usually that's going to be determined by the type of sample or by the parameters that you're collecting the sample for. There are certain parameters that you have to do what's called a composite. And that is often a actual series of samples that you have pulled from the same spot, usually over a 24-hour period. And depending on the actual flow of the sample, we're talking about water samples here, aqueous liquids. Depending on the flow of the liquid through that spot, it could be just an every hour grab X amount of grab 500 milliliters of sample or whatever it is, or it could be a flow adjusted average where you know that like in a wastewater treatment plant, you've got a higher flow during the day and a lower flow at night. And so during the day you are collecting more or less volume, and at night you're collecting more or less volume. Again, all depending on your flow and how things work. And so that what you do is you collect an accurate representative sample of an entire 24-hour period. Your grab samples, instead of doing that constant collection and constantly updating and getting more and adding to it, it's exactly what it sounds like. You grab one amount of sample out, and that is what you are collecting with. And again, how you do that is usually determined by the parameter that you're working with. A lot of your nutrients type things, those are often composite samples. Other things, bacteria or oil and grease, things like that, are usually a grab. And so a lot of the sampling process involves, it doesn't just happen that day. You got to make a plan. You've got to program there. You see that first picture we've got, that's just a representative automatic sampler that gets used to pull samples a lot. You got to set your program up. You've got to know your flow rates. You've got to know your sample amount. You've got to get the proper reservoirs inside so that you can collect the full volume of your grabs, or of your individual grabs to make the composites. And then usually what I've seen is that as the composite samples are collected at the end of the composite cycle, that is when the grab samples are acquired as well. And you can use those, the balers or the dippers that you see in those other pictures to get those grabs. Some samples, however, may even require special grabbing procedures. We'll talk about some special cases near the end of the presentation and go over some of the peculiarities of each one of those to kind of see how they should be handled. Once you've got your sample, there are lots of different preservation requirements. Most commonly, almost every sample gets held at a lowered temperature. So they get shipped on ice so that they cool down and the chemical activity is greatly reduced at lower temperatures. But then many samples or many parameters also have some form of chemical that gets added to them to preserve the sample that you have pulled, kind of freeze it in time so that whatever you have collected, it stays that way. And I've got a couple of the common ones listed here. Your nutrients typically are preserved with sulfuric acid. Metals typically are preserved with nitric acid. Your organics often get preserved with some combination of hydrochloric and sodium thiosulfate. Bacteria samples, sodium thiosulfate. A couple other things that I've seen, sodium hydroxide for cyanide, sodium hydroxide and zinc acetate for sulfide. And then depending on how you're doing your hexavalent chromiums, there may be a specific buffer that's required. I think there are a couple of other esoteric options out there for chemical preservatives, but those are generally what you use. There's some of them have, some parameters have some dechlorinating options that you can use beyond sodium thiosulfate. But that's generally the type of thing that you're going to be working with. When do you actually need to add that preservative? A lot of times there are, the preservative will be added immediately after the collection is done, or potentially even collected into a preserved bottle. So let's think about your composite sample, your composite sampler that you've set up. So it's gone for 24 hours and it has collected all of the sample that you're ready to use. And I think it usually pulls like 5 liters or something in total. I can't remember the exact amount, but it pulls a large amount, which is not what you were sending back to the lab, because sometimes you'll need to have individual aliquots for your nutrients, for your metals, maybe for your BOD, for your bacteria, and for cyanide. And so you've got all these different things that you're pulling samples for, but they all need different preservatives. So you don't sample into a preserved gathering collection container, but once you have completed your sample, you then pour into different bottles, and then that's when your preservation gets added in. There are instances where preservation can be added back at the lab or in your sample receiving area if you are within a certain amount of time. Certain samples, I believe some dissolved metals, can be filtered in the lab and then preserved with nitric acid, after which they have to sit for a certain amount of time to make sure that things get dissolved back in and are desorbed from the container wall. Other parameters such as orthophosphate will require field filtration, so you have to know kind of what you're working with there. But generally speaking, you're adding your preservative to the sample within about 15 minutes. 15 minutes has been the adopted time frame for field analysis versus lab analysis. So you're collecting your sample either into a preserved container, or you're adding preservative to the container itself, so that the sample is preserved for the proper parameters. There in the picture you see some preservation ampules like the ones that we sell. So that's an option, or we also, along with other bottle providers, have the option to get containers that come with a typical amount of acid or base or whatever added into them as well. What's important to remember when you're using those is that you should still check the pH of the sample after it's been preserved, because the actual preservation requirement is not X milliliters of sulfuric acid, but it is sulfuric acid to a pH of less than 2. So you need to double check once you have put that preservation in that you have actually achieved the state that you are looking for. Yes, your sample receiving people back at your facility are going to do this again. However, you should do it as well to ensure that you are doing the best possible job of preserving that sample for its intended analysis. Once the sample is collected and preserved, it's generally stored in a cooler on ice or with an ice pack of some sort. And the intent there, as mentioned before, is to lower the temperature of the sample and reduce the chemical activity. We all learned in our freshman chemistry classes that you speed up reactions by adding heat. So we can infer then by removing heat, by cooling it down, then we slow down or stop any chemical reactions from occurring, and we further preserve that sample in its state as collected. Occasionally, if your sample collection site is really close to your facility, you may not actually achieve any temperature change at all, much less all the way down to that less than 6 degrees, I think, or maybe it's less than 10 degrees. Less than 10 degrees for some, less than 6 degrees for some, depending on what you're looking for that temperature requirement. As long as you can demonstrate a downward trend in the sample temperature, then that is appropriate. And of course, always be aware of holding times. For most of your samples, getting your samples back to the lab, if you're collecting and getting them back to your facility that day, holding times generally aren't an issue, but it can be for certain parameters such as your bacteria samples. Those do have holding time measured in hours. I think the most current guidance is 8 hours for most of your bacteria. And then there are, of course, other short holding times, nitrates, orthophosphate, BOD, those are measured in hours, but that's 48 hours, so you've got about 2 days. So as long as you're getting in the same day, then you're usually okay. But being aware of holding time is important for your sample, especially when getting back to the lab. If you've got any question about stuff, it's always a good idea just to give your facility a heads up on your way in. Say, I've got X sample collected at X time, just so that they can have a heads up on what you're doing. How you collect your samples, or what you collect your samples in. Generally speaking, you're going to be using plastic or glass. So a lot of my information that I'm giving you here is coming out of the most recent 40 CFR Part 136. I think it's in Table 2 is the required containers, preservation techniques, and holding times. So that's got a lot of updated information in it, clarified certain holding times, clarified some temperature requirements, and so forth. But just about everything that they have listed as far as the container type breaks down into plastic or glass. And for most samples, plastic or glass is perfectly fine. Either one is acceptable. It really doesn't matter what you use. It just depends on your preferences, your lab preferences, whoever's the purchase price preferences, whatever kind of criteria makes you happy. Generally, it's fine for the plastic or the glass. There are some requirements, however. Some samples have to be done in glass. Some samples have to be done in plastic. Fluoride, for example, cannot be collected in a glass bottle. Organics cannot be collected in plastic bottles. You do have to pay attention to some certain ones. Oil and grease, we'll talk about that one a little bit later, has to be done in a glass bottle. And then there are a few of them that are specific on the type of plastic that you have to use. Generally speaking, polyethylene is your most commonly used bottle type, and that's overall a good choice to use. Some samples, however, need to be a fluoropolymer, PTFE, for example, or at a minimum have a PTFE lined cap. That's a common requirement on a lot of the sample bottles. Some sample bottles, such as your bacteria, need to be any type of plastic that can be sterilized in an appropriate manner. So usually that's polypropylene, polystyrene, something along those lines. And those are really the types of plastics that typically get covered in this. So you do need to be aware of what type of plastic you're using or whether you should use plastic or glass. Most of the time, plastic seems to be the preferred container, just because it's lighter weight and it's easier to dispose of after you're done. You can crush it a lot easier, it takes up less space. Lighter weight, obviously, better shipping costs. So most of the time it's plastic, and then after that it's glass for certain circumstances. The size of the container that you're using, does it matter what size? Effectively, no. However, the caveat has to be that obviously you need to collect enough sample for the analysis that you're running. Certain types of analyses, such as BOD or TSS, will historically require much larger volumes of sample than, say, samples collected for ion chromatography. A typical IC will use, I don't know, 6 or 10 milliliters of sample, and that 6 or 10 milliliters sample is good for all of the anions that you might be looking at. Whereas a BOD sample could use 500 milliliters to pour up all your different dilutions in your bottle. TSS sample might need up to an entire liter to filter, depending on the amount of solids present. So the amount of sample matters only in relation to the test that you are running. Certain samples, usually the extractable organics, your semi-volatile type things, they are actually looking for a liter size. They or ask for a minimum of 1 liter of sample so that you have enough sample to have your analytes be detectable. So some samples actually do have a minimum volume that is recommended for them. And then the style of the bottle, usually determined by the type of opening that it has. Let me pull up my pointer here. So we've got, effectively speaking, this plastic bottle here and this glass bottle here are essentially the same bottle. You've got, you know, about the same size, about the same shape. Everything's pretty close to the same, just plastic or glass. However, when you compare this bottle to this bottle, this amber glass to this clear glass here, again, those are, I believe those are about 1 liter in volume, but there's a large difference in the opening of the bottle. This larger wide mouth bottle is usually preferred by the field people because wide mouth bottles are really easy to get sample into. Don't spill nearly as much. It's a lot easier to pour into what you're using, and just an easier thing to handle. Your lab personnel often will prefer these smaller mouth bottles for the exact opposite reason, that it's easier to pour out of and direct that flow into whatever particular container you need, whether it be your graduated cylinder to measure something out, or a beaker for you know, some just pH adjustment or a meter analysis. It's easier to pour from a smaller mouth container. So that's up to you, again, as the user, to decide between everyone who is handling that bottle, what the best way to do it is. So there is no real guidance as far as the regulations are concerned in whether you use a large or a smallmouth bottle. It's all up to you as the individual. All right. There are some field parameters that you have to be aware of. I did a quick scan of the holding times, and these are the main ones that I saw. Sulfite, probably not nearly as often, but the other four, TRC, pH, dissolved oxygen, and temperature, are some pretty common ones that will need to be documented, and those have to be done, or should be done, in the field. Chlorine is a very volatile type of analyte, and it can dissipate over time. If you've got a couple hours between collection and getting back to the lab, that chlorine can all be gone by the time you get back. Dissolved oxygen will change because you're cooling the sample. As water gets colder, it actually has a higher capacity to store dissolved gases. So it can absorb more gases from the atmosphere and have a different dissolved oxygen content from when you originally collected it. pH, also temperature dependent. And if obviously you can't preserve it and still take a pH, because by preserving it, you change the pH. So leaving things unpreserved, the pH can go up and down depending on what else is happening in that sample. And temperature is very obvious. You're cooling the samples, so there's no way to get them back to the original environmental temperature unless you've taken that temperature and know what to get them back to. But if you've done that, then you know what the original temperature was, so you don't need to get them back to that temperature. So that's another one that has to be done there at collection. And those are done. These are just general representative type meters, field pocket meters that will do one or more of those parameters for you. Again, those are there's that same 15-minute window for getting these done, as we mentioned, for getting that preservation taken care of. All right, so we're going to start talking about some of our special considerations. The first one I want to talk about is volatiles. Volatile samples must be collected in glass and typically are collected in 40 milliliter vials. The smaller, that mid-size one that you see there on the left, those are your 40 mils. These are 60, these are 20. But a vial of some sort, glass vials, clear or amber can be specified by the method. There are some parameters that are light sensitive, and so should be collected in amber. Some parameters are not, so it doesn't matter. You can do clear or amber. Probably the most important thing about a volatile sample is that it has to have no headspace. Headspace refers to unfilled container, essentially. If you have that container standing up and you can see the top of the liquid and there's a gap between the liquid and the lid, that is headspace. You don't want headspace because volatile analytes, volatile organics, are so named because volatile means that they will evaporate. And if they evaporate in your container, then they are going into that headspace. They're going into the air that is above the sample. Then when you take the lid off, the air mixes with the outside air and you have lost everything that you are trying to analyze. So usually the guidance is that you fill the vial completely to the top with the meniscus. That's that little bubble held in over the top of the edge by surface tension with a meniscus on it, and then you place the cap down on top of that overflowing bottle and screw it down. And there's, I think this guidance is still, these words are still present in the guidance. A pea-sized bubble is all that you are allowed to have. And that is just to help ensure that you do not lose any of your analytes from evaporation out of the sample. Most of your volatile organic samples are collected with that septum, that rubber septum on top. And that's a special composite of materials, some blend of a nice cool rubber material and PTFE. Those are the most common layers that you get. And that's designed so that the sample collection vial itself actually goes directly onto the instrument that will be analyzing it. It has a syringe on it that punctures the septum and draws sample out, does its analysis, and then as the syringe pulls out, that septum is designed to close back in on that hole. The hole is still there, but the material has closed in around it and closed that hole off so that it is once again airtight and you've not lost anything. You're not allowing air to get back into the sample or analyte to leave the sample. If you are adding preservative to the vial, usually you will want to add the preservative first. You'll have a pre-measured amount of a certain concentration of your acid and or the sodium thiosulfate that will already be in the vial. You pour your sample in carefully to just overflowing so you create that meniscus and then put the cap on. And the reason you want to do it in that order is so that you do not lose any of the preservative. If you were to fill the vial first and then add preservative on top, you may not have enough preservative actually make it down all the way into the sample itself to do that particular preservation. Next special case, low-level mercury. Those of you who have worked with low-level mercury know how excitingly challenging this can be. Low-level mercury is called that because it does get down to amazingly low levels. It's going down into the micrograms per liter range. Often that's referred to as parts per trillion. There's not even a trillion people on this earth, so if you're looking for 1 part per trillion, that's less than 1 person present on the earth at this very moment. That's the kind of level that you're looking at. Everything that's involved in low-level mercury sampling has to be specially done for that low-level mercury. The sample collection bottles, the gloves, the preservation supplies, usually you will need to transport special water just for the event. Everything needs to be kept meticulously clean for your low-level mercury sampling. It uses the clean hands, dirty hands technique. Usually you have to have 2 people there, one person who's got the dirty hands, who is actually going to be handling everything, opening containers up, opening bags up, doing all of that, and then one person with the clean hands who is only handling the sample itself. And that's to make sure that you keep things as clean as possible. You've got to do special blanks when you're doing your low-level mercury. You've got to do a trip blank that's been done at the lab, filled up at the lab, and it makes the trip out to the site and then back to the lab with you. You've got to do field blanks where you are pouring water into a container right there at the same spot where you're pulling your sample. You've got to do equipment blanks if you're using special equipment where you're rinsing your equipment off and collecting that rinsate to show that nothing has either been contributed to or left behind on your equipment. So there's lots of things that you have to take into consideration for low-level mercury. Often I've seen people gear up in full Tyvek suits to keep anything that may have collected on your clothes from potentially getting into the sample. So lots and lots of things that you have to do to make your low-level mercury sampling event a success. Oil and grease, also some special considerations. This one has to be a grab sample. Oil and grease are surface active analytes, and they will stick to any surface that they come in contact with. They rarely dissolve in the actual liquid sample that you've pulled. And so you can't do a composite because your compositor will keep some of the oil and grease behind on the tubing or on the pump mechanism or inside the container itself where the composite has been stored. So your oil and grease has to be a grab sample. And so a common practice that I've seen is that if you're doing your sampling, you actually rinse the sample bottle out with the sample that you are collecting so that if there's any kind of reaction going on, or just to give that last clean sweep of the sample container. It's being done with the sample itself so that you don't have to worry about contaminating with anything. You cannot do that with oil and grease because that will bias your collection high. If there is actual oil and grease in that sample, in the sample site that you're collecting, then you will be depositing more on the surface, interior surface of the bottle when you rinse it. And then when you go to actually make your grab, then you're doing the same amount again. So you're adding extra analyte into your bottle. Another thing to remember with oil and grease is that whatever is collected must be analyzed. You cannot collect a liter and then only analyze half of it when you get back to when the lab gets it. Everything that is collected for oil and grease in that container must be analyzed in total. And again, that's about surface area. Part of the process for doing this oil and grease analysis is rinsing of the sample bottle itself. And so you cannot rinse that if you have not emptied the sample bottle. It does not homogenize well in the bottle. You can't pour off equal amounts and expect to have equal analyte present in both portions. So the whole thing must be done. And oftentimes oil and grease samples are collected in duplicate at a minimum, sometimes triplicate or more. This is, again, because the entire volume must be analyzed, and so that doesn't leave any room for mistakes. If something happens at the lab, the QC fails. Occasionally, you know, I've seen samples get spilled, dropped, whatever. There needs to be backup. There's also additional QC requirements. Some of you may have heard of sample spikes, where they add, they take a separate sample analysis and they add some of what they're looking for to that sample. And so that they can compare that with the original sample result and see if the amount added is that much greater than what the original came up with. And so with that, you need an additional whole volume of what you have collected. So most of the time, oil and grease is collected in duplicate, possibly triplicates or more. So just be aware of that consideration for your oil and grease analysis. A newer analyte that is becoming of interest to the world at large. I don't know that there are regulations on this yet. I know it's been in some of the UCMR's lists, and there are labs that are starting to do PFAS, perfluoroactives. I don't remember what PFAS stands for. Per or poly, I believe both of them apply, fluoro something something. You have to, this is totally opposite of almost everything else that you are doing with your normal sample considerations. You do not use PTFE lined caps. PTFE is actually some of what will show up in the PFAS scan. The regulations call for HDPE containers. When you're doing your sampling, you actually are instructed to avoid particular types of products being used in the sampling or by the samplers. Any waterproof or spill-proof materials, field notebooks, your Tyvek suits or your Gore-Tex suits, those are both brand names. Those are all treated with fluoropolymer type coatings to make them waterproof or spill-proof. Sticky notes and other removable adhesives can either contain fluorinated compounds in them, or because of the adhesive nature, retain fluorinated compounds and potentially contaminate your sample collection. Decon 90 is a popular decontamination soap, and it actually has some fluorinated cleansing compounds in it. So you can't use any of that around your sampling area. It also talks about minimizing cosmetics, moisturizers. Certain sunblocks and insect repellents actually do have some of these PFAS materials in them. So you do need to be extra specially aware of those types of materials. All of this actually came out of the Environmental Lab Washington report. That's a monthly publication. Jerry Parr puts those out. probably many of you or your lab managers are aware of this, subscribe to it or whatever, but there is an article in the most recent one that talked about the guidance being given on PFAS sample collection. So that is something that will start to become a additional precautions to take. We talked a lot about aqueous materials. That's not all of the sample collection. There's solids. I'm not really going to get into the solids. That's an entire topic of conversation, how solids get done, mostly because of representative sampling. Aqueous materials are pretty simple just because most solutions are going to be homogeneous in nature. Obviously, you know, particulates can float by, or we talked about oil and grease, non-homogeneous in water. But generally speaking, your aqueous samples are going to be homogeneous when you grab that out of the stream, river, well, whatever it is you're doing. Soils are non-homogeneous. Wherever you could stick your shovel in one place and get a totally different result 3 feet away. And that's because soils or other solid materials are discrete chunks of things. It could be soils, got a few there, plant and animal tissue, sludge, waste out of a waste drum, out of a garbage can, out of your landfill. Some of the more challenging things that I've ever seen happen with TCLP analysis has been you get a 20, 30, 50 gallon container in full of stuff, which is the best term we've got for it. And they say, I need a TCLP on this. And you've got everything from insulation to oil filters to gloves to trash to who knows what stuck in there. And so how do you determine how to get a representative sample out? You see that T-handle sampler we've got there, that's a common soil sampling device. And then the template there is usually used in determining the size of the area to be sampled. The different program areas ask you to sample, you know, a certain size section, 1 by 1, 5 by 5, 3 by 3, whatever inches normally area that you have to sample from. There is another soil sampling program coming out called incremental sampling, and I believe that's going to start being used some in the Superfund sites when they start collecting their soil analyses. And it's actually, so instead of the smaller and smaller volumes that lots of labs and analyses are going towards, it's going to actually start asking for larger amounts being used. Instead of a gram, maybe up to 5 grams or 10 grams of soil being used. And the sampling parameters are collecting, again, larger amounts of soil to use that sampling in an attempt to get a more representative value, to get a better overall average of the entire site, as opposed to just individual locations. There is two classes, one in Philadelphia, I think, and one in Dallas coming up in the next couple of months that the EPA is doing that'll be talking about incremental sampling and how that works and where it's going to be used and how it can be used and advantages, disadvantages, all sorts of fun comparisons about how that's going to be happening. There's a little blurb about that in that same ELWR from this last month where I talked about the PFAS guidance. All right, so that's the kind of the end of my planned presentation. So we'll go ahead and start with the questions now. By the way, in case anybody was wondering, we've got 159 people online, which is pretty exciting. Thank you everybody for attending. I hope that you've enjoyed this. So we'll go ahead and start with the questions. Any questions at all? Looks like a couple of people may have not had any sound. Apologize for that. Hopefully everyone else did have sound. All right. Does not appear that we're getting any. Oh, there we go. Okay, we've got enough coming in. So we got it. Here we go. I got a question. What if there's not enough flow to collect oil and grease duplicates? Hopefully that's addressed in your SOP. My advice, and this is just my personal advice of how I would handle it. Pray that you've got another sample that can be collected in duplicate so that your QC can be satisfied. And then B, document the conditions in the area where you are collecting. There are provisions in the method itself that will allow you to, in the lab, add DI water to the sample so that it has equivalent volume across all of the samples that you're doing. That's one requirement of the method, that all samples be analyzed at the same volume. So it can be, the volumes can be solved in the lab. If there is not enough for a duplicate, then that is just something that will have to be noted in the chain of custody in the notes section. Usually there's a place to record notes for samples, and just note that duplicates couldn't be collected. There should be enough other samples coming in that will allow you to do duplicates on other things. If that is the only sample, say you're a smaller municipal plant and you only do that one oil and grease site, and that's all that you do, and there's just not enough to collect that volume, that's something that you'll definitely need to discuss with the regulator who receives the data, and let them know that certain QC can't be done just because of physical limitations, and discuss what kind of options there are. Possibly doing it on consecutive days may be something that you can do, but that's something that's going to have to be addressed on a case-by-case. Mercury, I believe the requirements for mercury are a glass bottle. Let me double check. I've got the chart here in front of me. Mercury, fluoropolymer or glass with a fluoropolymer lined cap. So yes, mercury generally, I don't know anybody that uses PTFE bottles for mercury, but you can. Generally speaking though, everybody's going to be using glass with a PTFE lined cap. It's also got some fun preservation requirements. The bromine monochloride or 12 normal hydrochloric acid. So that's a fun one. How deep should you collect aeration basin samples, or any sample? That's also a good question, and I believe that is typically addressed by the sampling plan itself. Most of the time, an aeration basin, I guess in your wastewater plant, when your permit is written, it should specify halfway or minimum depth or something that from where you're collecting. If it is not specified, and this is a general rule that I've encountered over and over in the lab, if things are not specified, then you make yourself valid by specifying how you do it in your SOP. If you then always follow that SOP, you will be compliant, at least with yourself. If someone comes in to audit you and then has a problem with the SOP, that can be updated and changed in the future, but everything that you've done to that point should still be valid because you complied with your SOP. And that's only if there are no other written instructions. You will almost certainly want to, for any body of water, go below the surface. You don't want to just skim the surface of the body of water. You want to go below the surface so that you get a well-mixed aliquot. But as far as the actual depth, that's going to depend totally on what you're working with. If you've got a lake, obviously you can't always go halfway down. And if you've got, a stream that's only, 6 inches deep, you may not be able to totally submerge. So that should, case by case, but generally speaking, totally submerged, and I would just feel better if you're at least, 2 bottle distances down inside the water, just to make sure you get a good representative sample. Someone says, I've seen oil and grease sampling done with an automatic sampler. How do you prevent oil from adhering to the tube, and is there a particular tubing type to use? That's a good one. I am not aware that automatic sampling for oil and grease is possible. There could be some nice fancy ones out there that have good PTFE tubing, and they're set up to do just a grab for that one particular thing and have a separate compartment. I don't know of them, but I guess theoretically it could happen. But it would have to make sure that all of those provisions are complied with. Just, but even then, it would still make me uncomfortable just because of the rinsing of all the surfaces with hexane that you have to do. So that would have to be something that I think you'd need to pass by a regulator just to get their okay on, because my understanding of the requirements there is that it shouldn't be done that way, just because of how you have to rinse the surfaces that the sample comes in contact with. Copper and lead, is it required a narrow mouth or wide mouth sample bottle for collection? I don't know, actually. I'm not very familiar with the drinking water provisions, so I am not the best person to answer that one. And that should be addressed in the drinking water sampling guide that you get from your state. I think they outline the requirements. If I think back to what I had always seen in the lab where I worked, they were the very narrow mouth bottles. Let me see if I can go back to that slide and show you what I'm looking at here. This type, here, let me minimize my screen out of the way. This type of container here with this really narrow one, I think it was, usually I saw them collected in glass or plastic, but something with a really narrow opening like this one is what I've typically seen. I don't know if that was actually required or if that's just what my lab ended up doing. So that would be something that I think you can find in the state sample guidance. A rep from your particular state told us if there's minimal flow for collecting oil and grease, a separate glass jar can be used to collect oil and grease sample. All right, so that sounds like good guidance from that state. I like that. Which states now monitor for PFAS? I don't know. I have not heard any specific states that are definitely regulating it. I know they are showing up on the UCMR, so the Unregulated Contaminants Monitoring Report, I think is what that means. That is municipal bodies of a certain size are required to participate. Municipal bodies below that size, they ask for a certain number of volunteers, and that it's kind of a area by area requirement. There could be some local regulations that I'm not aware of that are requiring the PFAS monitoring. I don't think it's regulated. I think it is all just for data gathering so that they know where things can be an issue, or what the general limits are, to know if what people can detect, what's available, what kind of regulations are realistic to set. So I'm not sure about that. Is adding the DI water in EPA 1664B, that is in some of the FAQs on clarifications for method modification that I've seen for 1664. And one of the requirements is that all samples be collected at the same volume, or all samples analyzed be at the same volume. And so the guidance is either to collect them at the same volume, or if you have samples that are below that volume, to add DI water to bring it up to the same volume as the other samples that are being analyzed. So that's in some accessory clarification documents that I unfortunately do not have a reference for. Heard you mention that orthophosphate requires field filtration, which we are not currently doing. Is it something that's specified as a requirement in the method? Is field filtration required for all EPA 300.0 analytes? So I'm going to read off of Table 2 out of 40 CFR, and this is line 44 for orthophosphate. In the maximum holding time column, it says filter within 15 minutes, analyze within 48 hours. It does not have that requirement for any of the other anions, chloride, fluoride, bromide, nitrate, nitrite, that you might do. So that's the only guidance that I have specifically for orthophosphate. So that's something that you can check with your regulator to see how they wish you to handle that. Yeah. Is it a good practice to sample wastewater VOCs through the grab function of an automatic compositor pump? I don't know enough about the automatic compositors, or rather the grab function of the automatic compositors. I have a tough time envisioning a way where that grab function would keep your VOC without the headspace in it. At any time that it's spent, if it's sitting there in a grab container, just sitting there with an open lid, which I guess is how it would have to do, you're going to lose VOCs through volatilization. So it's just not going to. I can't see how that can properly store the sample for accurate analysis. There may be one that actually puts it in a VOA vial and caps it and gets it with no headspace and no bubbles and makes it happen. I've not seen it, but that doesn't mean it doesn't exist. So I think that would be the best evaluation, is how it actually stores it. Is there a way that it can put it in a vial when it grabs? What area is proper for aeration basin collection? We're in sides, middle, ends acceptable. What's the appropriate? Oh wait, no, that's a different question. So proper collection for aeration basin. Again, if it's not defined in your permit, then you define it in your SOP. If the permit just says aeration basin, then obviously something out where it is well mixed, somewhere away from your inlet, out along the sides obviously would be easy access. If it's possible for you to get actually into the middle of it without anybody falling in, because we all know what happens when you fall in the aeration basin, that's a problem. Then the middle seems conceptually to be a good place for the mixing, for the best mix of your sample of your liquid there. But again, that would have to be something that you define in your SOP and possibly give reasons for reaching your definition. Appropriate field collection method for EPA method 625, semi-volatile organics, grab or composite. Why? I do not know the answer to that question. I think that semi-volatiles can be composited, I think, because by definition, they do not volatilize out of an aqueous mixture. The semi-volatiles have to be extracted through solvent contact, before they can be analyzed. So I believe that they are safe in a compositor, but I don't know for sure on that one. How much preservative should be added to a 50 milliliter sample for metal analysis? Should syringe filtering occur before or after adding preservative? So this one, you should always, for a dissolved analysis, you should filter prior to adding the preservative. And this is one of those cases I was talking about earlier where you can collect your sample, do not preserve it, send it to the lab, filter the amount you need, preserve that, and then preserve your unfiltered so you can do a total and a dissolved metals comparison. But I do know that for a dissolved metals, you filter it first, then you preserve it, and you have to let that preserved sample sit for at least, I think it's 24 hours and maybe 12 or 18. I don't remember the exact time frame. Check the method for guidance on that just to make sure you get that time frame right. Lead and copper rule should be wide mouth so the sample can be taken with good flow to catch the first flush. All right, thanks. I think that could be the correct guidance. I'm not 100% certain. Let's see here. It's a very clever question. Joe, we'll let that one slide. We can discuss that. You can email me or something. We'll talk about that one. What size filter should be used for orthophosphate? 0.45 micron. And you'll want to make sure to test your filters to ensure that they do not have any phosphate residue on them. Phosphate is a pretty ubiquitous substance, and it's going to be tough to make sure that it's clean. So check your filters prior to use and make sure that they're good and clean for that. PES, polyether sulfone, is usually pretty clean from inorganic ions. PVDF may also be another good choice just for general use. All right, we are out of time. We're a few minutes past time. I do appreciate everyone being a part of it here. Thank you so much for your attendance. Thank you for the questions that you've asked. And I hope that everyone has enjoyed it and gotten good information. We'll be sending out follow-up emails to let you know when the webinar is posted. It'll be on our website in the webinar section. You'll also see some links and some descriptions for future webinars. And yeah, thanks again, everybody, for being here, and have a great day.